All right, welcome to the next tutorial on TCP IP and subnetting. This video is just to give you a bit of background on TCP IP, a little bit on subnetting and the private address ranges as well. So we're going to look at IPv4 addresses. First thing we need to know is that IPv4 addresses are 32 bits long. All right, those 32 bits are then broken up into 4 octets, right, or 4 groups of 8 bits each. When written in decimal, each octet will have a number from 0 to 255. If you ever see a number over 255 in your IP address or your subnet mask for that matter, it means that you've made an error in your calculation somewhere along the line, or possibly just a transcription error. Each of the 4 decimal numbers are separated by a period. Example 192.168.10.155. All IP addresses on a network should be unique. Remember, your IP address uniquely identifies your system on a network, and in order for IP routing to take place, right, those IP addresses need to be unique. Subnet masks, like IPv4 addresses, subnet masks are 32 bits in length and also divided into 4 octets. When written in decimal, each octet will have a number from 0 to 255. There are only 9 possible values that can be in a subnet mask, and these will be discussed later. So unlike an IP address, which can have any value between 0 and 255, subnet masks can only have certain values, and we're going to look at those values in some of our other videos. Each of the 4 decimal numbers are separated by a period. For example, 255.255.224.0. Written in binary, a subnet mask will always start with a series of 1s followed by a series of 0s. Example is on your screen there. Please remember this. When you look at subnet masks, it will always be all 1s followed by all 0s. There will never be interspersed 1s and 0s. So a subnet mask can have your 1s and 0s in any order, but an IP address can have your 1s and 0s in any order, but your subnet mask will always have all 1s followed by all 0s. Your IP address classes are defined by the first octet, so the first number in your subnet mask before the period is what defines the class of IP address. Class A is 0 to 127, so any IP address that starts with 0 to 127. Please be aware that 127 is reserved for loopback testing, so in actual fact, you'll only really use 0 to 126 in a Class A address. Class B is 128 to 191, Class C 192 to 223. Class D is for multicasting 224 to 239. Now, if you look at some of my other subnetting videos in the 0 to subnetting in 1 hour series, we'll give you a clue as to how to calculate those very easily, right? So if you think you have to memorize them, you don't really. So watch those subnetting videos, 0 to subnetting in 1 hour, and you'll find an easy way to remember. Private and reserved addresses, very important. Private addresses and reserved addresses cannot be used on any public network. So you can use your private addresses on a private network, on a private LAN, right? But you cannot use it on the public internet. Addresses that start with 127, as we said earlier, reserved for loopback testing. So if you ping 127.0.0.1, that just tests whether TCP IP stack is working on your system. Addresses that start with 169.254 are reserved for API-IPA, automatic private IP addressing. So if your system's set to use DHCP and there isn't a DHCP server available for whatever reason, you will be assigned an IP address in the 169.254 range. So if you ever do an IP config and you get 169.254, chances are your system cannot contact the DHCP server for whatever reason. Private address ranges, there's a class A, B, and C. The class A private address range is 10.0.0.0 to 10.255.255.255. Your class B address is 172.16.0.0 to 172.31.255.255. And your class C is the one we've been using in our examples, 192.168.0.0 to 192.168.255. All right, the last thing I want to cover in this video is just basically CIDR notation, which is just a different way of representing the subnet mask. So instead of having to represent your subnet mask as 255.255.255.0, for example, you just simply put in the network address followed by a / and a number after the IP address. All right, as an example, we've got here 192.168.10.0 / 24, which is equivalent of saying we have a network 192.168.10.0, that's your network address, right? And we have a subnet mask of 255.255.255.0. So the / 24 there actually represents 255.255.255.0, right? The 24 is actually the number of ones in your subnet mask, or the number of network bits. And if you remember, your subnet mask is always all ones followed by all zeros, which means the first 24 digits in your subnet mask have to be ones. So your 255.255.255.0 is actually represented like this, right? And you can see there are 24 ones, right? 3 octets of all ones. So that's 8, 16, and 24. All right, a subnet mask of 255.224.0.0 written in binary, right, gives you the number on screen, right? As you can see, there are 11 ones. So if you were to represent that as CIDR, it would be /11. Please note that you always write your network address before the /11, and we're going to look at more examples on this when we do variable length subnet masks, or VLSM.